The even-odd properties are as follows. The sine of negative theta is equal to the negative of the sine of theta. The cosecant of negative theta is equal to the negative of the cosecant of theta. The tangent of negative theta is equal to the negative tangent of theta. And the cotangent of negative theta is equal to negative cotangent of theta. Now I have purposefully left out two of the functions because these four functions follow the same pattern. Okay? Now, cosine and secant of negative theta are a little different. The cosine of negative theta is equal to the cosine of positive theta. And the secant of negative theta is equal to the secant of positive theta. Okay? So you may be thinking, where can I use these, or how could I use these identities to help me work problems? Well, let's say that we wanted to know what is the sine of negative pi over 4. The sine of negative pi over 4 is going to be equal to the negative sine of pi over 4. So we all remember that pi over 4, we associate that with the point square root of 2 over 2, square root of 2 over 2. And we remember that sine is the y coordinate. So that means that this is equal to negative square root of 2 over 2. So another way to work this problem right here would be to add 2 pi to it and do all that. Have to use the reference angle chart and the salty C chart, but just by applying the even and odd property, I can work it out a lot faster. Okay, and it really makes, when you're taking the cosine or secant of something, it makes that a lot faster. Like the cosine of, let's say, negative pi. Now you could just add 2 pi to that and yada yada go on with that, but we can also, using the even odd properties, if you take the cosine of a negative something, a negative angle measure, you can just drop the negative sign. So that's the same thing as the cosine of positive pi. Alright, and we remember positive pi is on the negative x-axis, and if we have the unit circle, that point is negative 1, 0, and cosine is the x coordinate on the unit circle, so negative 1.